So then with this extra time that we will likely have at the end, we can ask any questions throughout the project. So if there's some things that maybe you missed in other projects after we finish answering all of the questions in we can others. And then you are going to be turning this packet in sorry, when are you turning this packet in? Tonight. Yeah, tonight by 8 p.m. So this packet gets turned in by 8 p.m. So we'll want to make sure that came off of there. You want to make sure that you have all of your stuff filled out. So if you don't have everything in that packet done right now, obviously nobody has number 9 done yet unless you did that project and filled it in ahead of time. But other than that, if you don't have things filled out from other projects, you want to ask those questions at the end. And or get them on your own through a friend or going back and looking at other videos, that kind of stuff. Does anybody have any questions at this point about the packet, project space packet being due today at 8 p.m.? Maybe not. Okay. Well, going back to our slide then here, we do have something else coming up due, and that's the study guide. The study guide was posted on Sunday evening, you know, this at the beginning of the week. And so you have had it for a little bit of time. It's not due until next Tuesday. So next Tuesday is our next class, and you want to have your study guide turned in by then. So your study guide is due Tuesday by noon. So before class, let's have that in. And I don't know that I actually set a date. And to be honest, I don't know what time I close the submit box. It actually might be later than noon. I'll double check, but it wouldn't have been any earlier than noon. So let's just say that it's due by noon. That should work just fine. And then we'll have a chance. It's good to have your study guide done by then. Oh, okay. Somebody sent me a message. Evan, thank you, Evan. Evan said that on NTB it says the presentation packet is due by 10. Okay. Oh, it is, huh? Okay. 10, did I say 10 p.m. or 10 a.m.?
Said 10 a.m.
10 a.m.? Okay. Oh, I thought I gave you a little more time than that. Okay. Well, I could go back in and change it to noon. Just have it in by, and I will do that. I'm going to make something better. Then you'll just have it. I just want you to have it done before you come to class on Tuesday so that we can review. And we'll have a review on Tuesday and on Thursday. And I have some games and stuff ready for you. I've got a Jeopardy game that I made. I've got a couple Kahoots. There's a few Kahoots that I would love to play also that you guys made for your projects that we didn't get to show. So we have more review things than we probably have time to use. So we'll play some games on Tuesday and Thursday, and I'll definitely start Tuesday's class with, you know, reviewing anything on the study guide that you want me to review first and foremost. And then I will be posting the answers to the study guide on Tuesday after class. So that is why you will want to have your study guide done beforehand. You know what? I could actually post the answers on Wednesday. That way I could give you guys an extra day. I mean, it would still be late if it's not in on time, but I wouldn't mark it 0. I'll give you an extra day to turn it in just in case. And then I'm going to post the answers, and then you won't be able to get full credit anymore. I'll probably give you partial credit if it's late, but once the answers are up, you know, you can't get full credit anymore. Okay, so what we're doing today is A Star is Born presentation brought to us by Reese, Saya, and Zoe. And then we're going to take their little quiz. Now, their quiz was required for their grade. but you do not have to submit the answers to this quiz. But we are going to do it together, just as an extra review. And this particular quiz is not a Kahoot, it's a Word document. So I posted it also on Sunday, and that is something that you should have handy to answer. And that looks like, let's see, oops, I stopped the share instead of, I'm pretty sure I have that up here, yeah, right here. Is the quiz. So it's got, let's see, 10 questions on it. It's a Word document. And there is, it looks like one multiple choice question, one true, false, and a couple of like fill in the blank or short answers. So again, this doesn't have to be turned in for a grade, but we will do it together after their presentation just to see how much we learned, and as an extra review. Okay. Anybody have any questions or anything you want to say before we start? And is everybody in here? I think everybody is in here. So I hope everybody has is safe and inside where it's dry, because I know the rain has been coming down, and I was hoping it didn't knock anybody's power out, but I guess if you're here, your power is on and your internet is on. Mine was down for a short bit this morning, and I was afraid I wasn't going to be able to have class, but here we are. Okay. Oh, Kyla's there. Okay, great. Good timing, Kyla. We were just getting started. Glad you could join us, Kyla. Just a quick little blurb since you just joined us just briefly. This is our daily slide. We are turning in our packet that we've been working on by 8 p.m. tonight, and our study guide by noon Tuesday. Even though it says 10 a.m., I will change that. And now we are going to take a look at Saya and Reese and Zoe's video. It's really good. You'll enjoy it. Okay. All right.
You're on. Welcome. We are doing a project about the life cycle of a star. Yeah. Okay, so this is by Reese, Zoe, and Saya, and it is project number 9, A Star is Born, the Life Cycle of a Star. So how does it begin? A star begins as a nebula, which is a swirling cloud of gas and dust, pulled by gravity, and it clumps together. And sometimes they get so big that they develop their own gravity. And hang on, I'm gonna hide you guys. So there we go. Okay. So the clump gets so big that it collapses from its own gravity, and this causes the material at the center of the gas clump to heat up. This hot core is the beginning of the star. This process takes around 1 million years from the point where it's a dust cloud to the point where it's a hot, spicy ball of light. And a good metaphor for this would be a vacuum. On the floor, there's dust, dirt, pet hair, stuff. Where the vacuum sucks it up, it condenses into a big, nasty clump. And the difference is instead of dirt and stuff, it's just beautiful space dust.
I like the comparison there of it to dirt and dust and pet hair. Okay, so your first question was, how is a star born? So this is, you know, kind of your answer here. Of course, not expecting you to copy that, but basically what Reese is explaining right here is that I think it's Reese's voice, is explaining how a star starts off as something called a nebula, which is a swirling cloud of gas and dust. And it's pulled together by gravity and clumps together. So maybe that very first sentence right there would be a pretty good answer for how a star begins its life. And then you might even add that, you know, at a certain point it starts to ignite, or you know, once all of the dust and gas gets close enough together by gravity and gets really, really hot and it ignites, now it's an actual star. So, all right. And we're going to move on. So our next question we're looking for is, what size star is our sun? Is it a small, a medium, or large? So this will be a quick answer.
So what happens next can take 2 paths depending on the size. So if it's an average size, it turns into a red giant, and it heats up around 2,200 to 3,200 degrees Celsius, which is about 4,000 to 5,000 degrees Fahrenheit. This temperature change causes the color to appear red, which gives it the name red giant. And then stage 3 for an average star is it lives a few thousand to a billion years in the red giant until it runs out of helium in the core and the fusion stops. It's the reason it's so hot. The heat is the byproduct of the chemical reaction that happens in the center of the star when the hydrogen converts into helium. So after it runs out of that helium supply, it begins to shrink until a new shell of helium reaches the core. When this happens, it ignites super fast, and the outer layers of the star explode off into huge clouds of gas called planetary nebulae. And this is a picture of one. I'm not sure if it's like an artistic rendering or an actual picture, but you can find like any information on it.
That actually is a picture that Hubble Space Telescope took. I do believe, I've seen that picture before. I do believe that's a real picture taken from our orbiting telescope.
So the final stage for an average-sized star is when only the core remains. It turns into an extremely hot white dwarf, which is hotter than 180,000 Fahrenheit. It very gradually cools down over the next few billion years. This is the final stage of an average-sized star's life cycle. And here you can see a white dwarf surrounded by rings of dust. So what happens if it is an average? Let's find out. What if it's a massive star? So after the nebula dust forms into a really big star, it follows the same path as stage 2 of an average star, except it turns into a red supergiant, which is the same concept, but completely colossally huge. So this is a picture of the sun compared to the planets. You can see Earth is mega tiny. And this is a red supergiant compared to the sun. You can't even see. So what is...
By the way, I thought they said it in here somewhere. But the size star that our sun is, I know that's the question you're kind of looking for right there. Reese, Saya, could you step in for a second? And what size is our sun? Is it a small, medium, or a large star, compared to other stars?
It's medium, because there's stars that are bigger than it, but there's also stars that are a lot smaller, so it's kind of average in the middle.
Yep, very good. Thank you. Okay, so we'll move on. And what we're looking for now too is a couple of things. What life stage is our sun in now? So this would be a question about like a medium-sized star and where it is now. And then where and how does a star shine, or how does it create its energy? So we're looking for those right now.
This is just to help you get some perspective on how truly massive red supergiants are. So the stage after that for a massive star is when, so in these red supergiants, other nuclear fusion processes occur alongside the usual helium plus hydrogen. These include oxygen, nitrogen, and iron. Once the core becomes completely iron, nuclear fusion ceases. Since energy isn't being produced anymore, the star begins gravitational collapse. It heats up around 100 billion degrees, the iron atoms crush together, and the repulsive force of the nuclei overcomes the star's gravity. The core of the star explodes in a shock wave, which we call a supernova explosion. So what happens after this is one of two outcomes. If the explosion continues long enough for electrons and protons to combine to form neutrons, it turns into a neutron star. And if the collapsed core is larger than 3 solar masses, which are about the size of our sun, then it forms a black hole.
By the way, so this isn't necessarily going in order of the questions I asked on your sheet. So she's talking right here about what happens to a massive star once it runs out of fuel. This is number 6 on your sheet. And then also, do all stars go through the exact same cycle? Why or why not is kind of sprinkled within here. And then also number 8, how are black holes formed? That's going to be coming right next.
Actually, the dust and debris left behind by this process are recycled in different nebulae, different stars, or different planets, and the process begins anew. And this is a diagram of the whole process. And thank you for your time.
Okay. All right. So I'm going to stop share here for a second. Okay, so yeah, you probably do have a few questions for them, and I want to kind of let you know that the questions that I've asked in your presentation packet are not the exact same questions that I asked them in their research, which is why it may seem like not everything was answered or that it wasn't in this order. That's not their fault. There is something that is not in your packet that I kind of want us to write down. I kind of want us to actually know what the life cycle of the stars is, like to be able to list the stages for a small star, small medium-sized star like our sun, and then the large and massive stars. So we're going to do that at the bottom of our paper, and I'll help you out there, and Reese and Saya will be able to help us out too. So you probably, before we get to that point, and I'll use their diagram to help you with that. We might have something in my eye. We might have a few questions. So anybody have questions for them? Let's see, you can raise your hand. Jaden, what's your question, Jaden? I'll unmute you. There you go.
Okay. How are black holes formed, and do all stars become black holes?
Okay. Reese or Saya, do you want to help with that? First, let's say, do all stars become black holes?
So not all stars become black holes, only really, really big ones do. And I'm pretty sure it's because they get so big, they collapse under their own gravity and it sucks everything in.
Okay. Yeah, exactly. They have so much mass that when, and all of that mass has to like gets sucked in because there's so much gravity. Remember in Alex and Chase and Zane's project earlier this week, we talked about, more mass, more gravity, and closer together, more gravity. So as these particles get closer and closer, and it's because there's so much of it, because it's such a big star, yeah, these black holes form. Gravity makes it collapse in on itself, because nuclear fusion is keeping it circular. And once nuclear fusion, it's the outward force. Once that stops, gravity just pulls it all in, because there's nothing forcing it out. There's no balanced force there. Okay, any other question? Let's see, I see others have their hand up. Let's see, Kyla, what's your question?
So my question was not really a question. It was just, could you go back to the last part of it, because I couldn't see it. Like I got to it, but I just couldn't get to it.
Like when we're talking about black holes?
Actually, can you go back to the one that says what happens when a massive star runs out of fuel?
Yes, I think so. Okay, let's see. Right around here.
Once the core becomes completely iron, nuclear fusion ceases. Since energy isn't being produced anymore, the star begins gravitational collapse. It heats up around 100 billion degrees, the iron atoms crush together, and the repulsive force of the nuclei overcomes the star's gravity. The core of the star explodes in a shockwave, which we call a supernova explosion.
So basically, what she is explaining here is that it, here we go, it runs out, like nuclear fusion stops, and then it explodes. There's a supernova explosion, and I like the picture here because that is a picture of a supernova, I do believe. And then all of those pieces then get pulled together by gravity, and it collapses in on itself. So nuclear fusion stops, and gravity, or nuclear fusion stops, there is a supernova explosion, and then gravity pulls it in on itself, and a black hole is formed. Hope that helped, Kyla. All right, and what other questions? Let's see. Somebody's chatting. Can you pause it? Where, Jaden, where should I pause it? Is that too late? Oh, you asked me that a while ago. Sorry. Can you go back to the very last slide? That's what Jaden's asking. Okay. Last slide. It's probably right. Oh, we haven't shown the models yet. That's right. Still have the models to show. I thought that was the model. I forgot. Okay, so this is the last slide, I do believe, Jaden. Is there anything, Jaden, you'd like us to discuss on it? Get rid of it. I don't know if you can see my chat box or not, but okay. Yes, Liam.
I'm kind of confused on the answer to number 5.
Okay, so question number 5 is asking, what stage will our sun be in once it runs out of fuel? And what's its eventual outcome, the final, the final stage? So this isn't the final stage of a massive, this is the final stage of a massive star's life, the slide we're looking at right now. But Reese told us that our sun is a medium-sized star. So why don't you explain, either Saya or Reese, how a star like the size of our sun, a medium-sized star, what happens to it once nuclear fusion stops? Reese or Saya with that one? Reese or Saya, anybody? What happens at the end of a medium-sized star's life?
So at the end of the medium star's life, it turns into a white dwarf.
Yes, it does. Right. So number 5, what stage will our sun be in once it runs out of fuel? It'll be a white dwarf. And is that written there? Oh, that's probably in the next slide, isn't it? Is it in the next slide? Maybe it's after that.
The star explode off into huge big star. It follows the same path as stage 2 of an average star, except it turns into a red supernova.
Okay, so basically, yeah, she explained it within that description on that last slide. So if a star is a medium-sized star, like our sun, once it, oh, there it was. Once it runs out of fuel, it will have a little, it will expand into a red giant. So instead of a red supergiant, it's a red giant. And then after red giant, it will nova. So there'll be an explosion like you see in this picture, but it just won't be a supernova, so it's not as big. And then it also, gravity pulls it in on itself too, but it becomes a white dwarf, like Reese was saying. A white dwarf would be the eventual outcome. And honestly, after it's, a white dwarf is still really, really hot, but it's dim, and it's pretty much the star is at the end of its life, and it's pretty much dead. But once it eventually has no heat left in it at all, it's called a black dwarf. So eventually our sun will be a black dwarf, but white dwarf is okay for your answer there. All right, any other questions? There are. Nova, what's your question?
I think it's number 4. How does a star shine? And then how does a star produce energy?
Okay. Saya, would you like that one? How does what's the star do to shine and make its energy? You've talked about it right here and in a few places.
It seems like no one else in my group wants to take the question, so I'll just answer this one.
I guess I'm not hearing from Saya, and I don't think Zoe's here.
Yeah.
I don't see Zoe. Huh. Okay. Thank you, Reese.
So a star produces energy and shines via nuclear fusion, which is the heat comes from a byproduct of the chemical reaction that happens in the core, that is.
Right. Thank you, Reese. That's
Thank
right.
you.
Nuclear fusion, this word right here. Make sure that you notice that it's nuclear fusion with a U, not fission. Not too long ago, we talked about nuclear fission when we were talking about atoms and like the atomic, our other project, Scientists of the Atomic Theory. Nuclear fission was about splitting the atom, which, of course, led to nuclear power and nuclear weapons. This is the opposite process. This is when atoms are fusing together versus splitting atoms apart. But they both produce a tremendous amount of energy. But fusion is how a star makes its energy. That will definitely be on the test, of course. So make sure you know that. All right, thanks for asking that question. John Ben, what's your question?
Mine got answered. I just forgot to put my hand
Oh,
up.
okay, great. Oh, and that reminds me, I still need to go back. Don't let me forget to show their model yet still. Okay, Libby, how can I answer your question, or how can we answer your question?
Okay, they might have already said this, but I just didn't catch it. Which stage is our sun in now?
I don't know if they said it or not. I was wondering, I was kind of waiting for that too. Reese or Saya, did you name the life stage that our sun is in right now?
I don't think we did, but it's in stage 2 or the main sequence.
Yes, great. So
Thank
main
you.
sequence. Make sure you write it as such. The term for this life stage is main sequence. Which is middle age for a star. And that is where our sun is right now. It's right smack dab in the middle of its life. It's about 4.5 billion years old right now, and it'll live another 4.5 billion years before it turns into a white dwarf. Well, actually, until it starts expanding into a red giant. So yes, main sequence is the answer to number 3. All right, how about Jaden? Did you have another question, Jaden, or is your hand still up from before?
Yeah, I had another one. Well,
Okay.
the last slide, you didn't go to the last slide. You know the one that has the little diagram showing all the life stages?
Yes, and I do want to go back to that. Okay, I can go to
Yeah,
that.
because you wanted us to write that, right?
I do, except that it's not 100% complete. And it is, there it is, a typical diagram that you find online. And it is, yeah, this particular one is all over. Oh, Brooke raised her hand too. Okay. And there's nothing wrong with it, except that it's kind of, there's a couple of things that I want you to know that are like right here that it leaves out. And I just want to add them, but this will be great. So Jaden, did you have a question about it?
No,
No,
that's
you
all.
want me to pause on it? Okay, sure. Brooke, how can I help you?
Yeah, I have a question on number 7. I don't know if you guys went over it or not, but I didn't catch number 7.
Okay, so question, and you know what? Even by looking at this right here, this diagram that we're pausing on, Brooke, you can probably answer the question. What do you think by looking at this, Brooke? Does it look like all stars go through the same cycle? Can you tell what you're seeing here? I don't know, maybe you can't. So here we see that you've got this nebula, which is how all stars start, as this cloud of dust and gas swirling around. Gravity pulls it all together. It starts clumping together. And then an average sized star, like a smaller or medium sized star, goes along this path. And if it's a larger star or a really, really massive star, it goes along this bottom path. So the answer then would be no, all stars don't go through the same life cycle. And why? Let's see, does it say why? Oh yeah, why or why not? It does. So why do you think, Reese or Saya, do you, why don't they go through the same cycle? Or what makes it one star go one way and another star go a different direction?
The size of the star is the difference.
Yep, exactly. The size of the star, how massive the star is. So a small or a medium-sized star like our sun, which is medium or average-sized star, is after it's a nebula, it's going to become a protostar. So if everybody could take a moment to write some the stages down at the bottom of your paper, because I do ask a question on this on the study guide. It's the very last question on the study guide, and I do have the test mostly written, and I do actually ask 2 questions about this. So I do kind of want you to write it down. And I really thought I had a question number, I thought there were 10 questions to this project, and I think that I left 2 of them off when I made this packet. So I think that's why they're missing. So we're gonna add it, no biggie. So let's make, you could even draw this if you wanted. And by draw it, I just mean like you can make circles, you know, that are smaller or bigger. And, you also want to write the names down underneath it. So we're going to start off with a solar nebula. So draw a circle, maybe you make a swirling bit of gas and dust and call it a nebula. You can call it stellar nebula or just nebula, it's fine. And then the next step, and it's not shown here, and I want you guys to put it in, and it's for both size stars. So right here where this arrow is going from nebula to average size star and the arrow going from nebula to massive star, before we go there, put protostar in. Protostar, P-R-O-T-O-S-T-A-R, protostar. That's a baby star. And that is missing in almost every diagram online for some odd reason.
Are we supposed to do that on both sides or just one?
Yeah, so if you're making 2 different lists, do it on both sides. And if you're drawing it kind of like this, you know, you can have the first 3 stages are going to be the same no matter what size star. And it's not until we get to the 4th stage, and I know it looks like the 3rd stage here, but it's really the 4th stage because protostar isn't in there. Once we get here, they merge, or not merge, I'm sorry, they diverge and go their separate ways. So first set or stage for all, nebula. Second stage for all or for both is protostar, which is baby star, and that's not listed here. And then the 3rd stage for both again, and this it's shown except it's not named properly, or at least the way I want you to know it, and that's main sequence. So instead of average star, massive star, write main sequence. And you could put main sequence average star and main sequence massive star if you would like, but they both go through main sequence stages. So nebula, protostar, main sequence, first 3 stages in all stars' lives. And then stage 4 is where they diverge. So a smaller medium-sized star is going to become a red giant, whereas a massive sized star is going to become a red supergiant. The only difference is the word super here, because it's super big. And then they both will explode after this stage. It's called a nebula, a planetary nebula here, but basically what I would call this would be a nova, and then you got a supernova. So smaller medium-sized star, a nova, which is a little explosion, and the large stars, supernova. Difference again here is the word super. So rather than write nebula, write this as nova and supernova. And then if it's a smaller medium-sized star, after it explodes, it's nova, it becomes a white dwarf. And that's basically a dead star. Eventually it'll become a black dwarf when there's no energy left on it. And then if it's a large star, after a supernova stage, it'll become a neutron star. But if it's really, really massive, it'll become a black hole after its supernovas. So there are actually 3 end states of a star depending on its size. So a small medium star will end its life as a white dwarf, a black dwarf. A large star will become a neutron star at the end of its life, and a really massive star will become a black hole at the end of its life. A star the size of our sun will never become a black hole because it's not big enough. And that will be a question on the test. That was another question that was supposed to be in this packet that somehow got left off. Will our sun ever become a black hole? No, it's not big enough. And then you've got your life cycle. So is there anybody that has any questions on the life cycle and how to write that? Let me take a look at everybody, see if everybody is hearing. You can put your hand up if you have a question or a concern or you didn't understand. All right, I'm not seeing anybody. Okay, that's good. Let's finish up the presentation here with their model that they talk about towards the end here. All right.
And this is a diagram of the whole process. And thank you for your time. Okay, so with the whole system, I have it drawn out. It is kind of watercolor, so might be a little hard to see, but it starts with the stellar nebula, and then it branches out into each step. So some of these might be a little harder to see, like the yellows and the other one, which is the neutron star, but it goes through each step. The average star, red giant, planetary, nebula, and then the white dwarf for the smaller ones, and then the massive star, red supergiant, supernova, neutron star, or black hole at the very end. I think we're good.
All right. And that was that. Okay. All right. So that was that last presentation. And let's take a look at their quiz now. Let's see. Oh, I should let you guys know that Saya was saying that her internet is having some trouble right now because, and the audio is really bad. So Reese, I don't think your partner was trying to leave you high and dry. I think she's having internet connection issues, which probably due to the weather. And yeah, okay. And she's having trouble with her mic. Sorry about that, Saya. I didn't see it till now, but we forgive you. Emily, did you need me to repeat anything? I see a message from you too, and I don't know if you got your question answered or not. So Emily, raise your hand if you need me to answer anything else for you.
No, I'm good.
Okay.
Her model explained it. I'm good.
Awesome. Great. Okay. So there was this little quiz that they wrote for us. And again, in case you weren't here at the beginning of class, just reminding you that you don't actually have to turn this in, but it's going to review what we just learned and see if you were paying attention. And so how does a star's life begin? What do we call, and this is going to be up for other people to answer besides Reese and Saya, actually other than Reese and Saya. Who can tell me what do you call that first stage of life that all stars start with? Trying to see who can. There is a way I can see everybody's hands in a better way. I know there is. I just can't figure out where it is. Oh, I think I know. No, it's not there. Okay, well, that's fine. How about, is anybody raising their hand? Nobody is. Okay. Well, that would be starts with an N. It's also in the second question. Nebula. Okay, and if the answer to the second question is what I'm thinking it is, I giggled about this and said I liked this analogy or metaphor. Who can tell me what Reese and Saya and Zoe used as a metaphor for a nebula. It was funny. Nova.
They use the vacuum with like all the dirt and the pet hair and stuff.
Yeah, right. Dirt, dust, and pet hair on your floor. Yep, that's right. Thanks, Nova. Okay, question 3 was a multiple choice. How many paths could the cloud of dust take? So I think what that's asking basically like, okay, so cloud of dust is the beginning of a star's life. So how many different life cycles could there be? Remember, there were different size stars determined which path it would take. How many different paths were there? Who's got this one? Oh, come on, guys. You got this. This is easy. You just don't want to answer it. Uh-huh. All right, I'm just going to call on somebody. All right. Hey, Donovan. Hi.
Hello.
Any chance you would know how many different paths a star could take? How many different life cycles we discuss?
3.
Yeah, good answer. Right, 3. 1 for the small, medium-sized stars, 1 for a large star, which large star, oh yeah, so small, medium stars would end up becoming a white dwarf at the end. Large would become neutron stars, and if it's really massive, they become a black hole. So there's 3 different paths that a cloud of dust called the nebula could take. Question 4, in stage 2 of the star's life, what makes the color of the star appear red? Okay, so they're calling that stage 2, but I believe that's really kind of like our stage 4, like the supergiant and red giant and red supergiant. I'm assuming they're referring to. So what makes the color appear red? Anybody? Reese, what makes the color become red?
What makes it become red is the temperature change from when it heats up into red giant or a super red giant.
Aha, the temperature change. Okay, yeah. And it actually, well, depending on the size of the star, for the most part, it gets cooler in the temperature. And therefore, remember in previous lessons, we learned that a red star is actually cooler than a blue or a yellow. So blue is the hottest, then yellow, then red. So they're getting red, so they're cooling down. So that was a good question, actually. Not one, I don't know if they specifically said the answer in the presentation, but one that you could have drawn from other projects and applied that information. Somebody, oh, Hannah's got to leave. Okay, bye, Hannah. Take care, hon. Okay, so every single star becomes a black hole eventually. True or false? How about give me a thumbs up if you think it's true and a thumbs down if you think it's false. Every single star becomes a black hole. Everybody do this one. I only see one thumb, and it's going the wrong way. Come on, guys, are you with me? I know you know the answer to this. Do all stars become black holes?
Thumbs down isn't an option.
Oh, thank you. Thank you. That's the problem. Oh, okay. I see. All right. Show me a thumbs up if you think it's true. Show me a thumbs up if you think it's false. All right. Yeah, that's correct. It's false. Thank you. And thank you for whoever told me that it was thumbs down wasn't an option. I didn't even think about that. I kind of actually did know that. But okay. Share a fact that you thought was interesting. Okay. Would anyone like to share something that they thought was kind of cool or interesting about stars and how they live and die? And by the way, I hope you know that stars actually are not really alive, so they don't actually die. We use these terms kind of loosely as if they were animate objects that, breathe and, reproduce. They're not actually living, even though they do go through different cycles, and they do eventually, they are born and die in as much as they are formed and then fall apart. So yeah, just so you know that they're not actually alive. How many years does a star live as a red giant? Oh, I don't remember that. Actually, I'm not sure I know the answer to that, but it was probably in the presentation. I'm sure it was. Anybody got that answer? Reese, how long was that a star lives as a red giant?
Okay, let's see here. Ooh. Can't find that. I thought I had that in here.
You did too. Okay, well, that's all right. I do know, use the chat. Okay, I do know that the stars.
Oh, wait, I found it.
Oh, you found it? Okay.
It's on the wrong slide. It lives a few thousand to 1 billion years as a red giant.
Okay. Oh, am I on a slide and
No.
not on the actual quiz right now?
No, you're on the quiz.
Oh, okay, gotcha. Okay, what'd you say the answer was again? I'm sorry.
It lives a few thousand to 1 billion years.
Oh, okay, a few thousand to 1 billion years. Okay, great. I know that star spends the most of its life in the main sequence stage, which is where the sun is right now. That's the longest stage. Okay, and hey, Reese, is there anything that you found interesting? What was your most favorite part of this project?
The thing that I found interesting, I had no idea that it takes 2 different paths. I thought every star was just like, poof, there's a star and then it died. I don't.
Okay.
I
Yeah,
knew pretty
so you
much
didn't
nothing
realize that the size affected like how it eventually looked and acted, so to speak. Okay, great. And Saya, if you feel like chatting what you think your most interesting part was for you, I would love to share it with everybody. If you can do that, I will share it. I'll be watching. And then at the final stage of a star's life, it becomes an extremely hot blank blank. Well, I'm assuming this means like a small or medium-sized star's life, I think. So it would become an extremely hot what? It's a color and then a size name. Anybody got it? Nobody wants to take this one on. It's a white dwarf. Okay. And let's see. Saya did say something. She says, it was fun to look at the images of the stars and comparing what the steps look like. Yeah, they are really pretty. I do like looking at the pictures. Hubble Space Telescope has taken some fabulous pictures that you would swear were not real, but they are. So, and I think another project or two we've seen some Hubble illustrations, I'm sorry, Hubble pictures in other projects, and these guys had some great pictures of Hubble in this presentation too. Okay, so if the star is not normal at stage 2, I guess normal meaning like small or medium. If the star is not normal at stage 2, it turns into a what? So what does a larger star turn into? Instead of a red giant, it turns into a anyone? Trying to figure out if you guys just really don't know or you just don't want to answer. And I can't tell. So, well, it turns into a red supergiant. Okay. All right. All right. What does the photo, let's see, what does the photos of the comparison of the Earth and the sun and the red supergiant show? So they did show, yeah, that picture at the end where there was, oh, why don't I don't have the video anymore for some reason. Okay, well, you might remember seeing it. What was the, can't get to it. So what was the purpose of that picture? What did it show us? What about the sun? I think it showed us something about the sun. It's one thing it showed anyway. Well, I believe it was showing how the sun was a pretty average sized star. And it was much, much bigger than the Earth. And all stars are much, much bigger than the Earth. And our star is pretty average in size. There's stars that are smaller and stars that are larger. All right. Okay, so that was the quiz. I didn't have very good participation on that. Okay, so, well, there is just a couple minutes left. And I thought we might have a little more time than we did. The quiz took a little while. To answer any other questions from the packet, we can still do that. I don't mind hanging out as long as we might need to. And I have office hours later today too. So I think we've answered all of the questions in today's presentation. And I know we have throughout these last couple of weeks answered every question in the packet. But if there is anybody, oh, Donovan does have a question. So yeah, Donovan, go ahead.
I was wondering, what was number 8? I didn't catch that one.
Is question 8, how are black holes formed and do all stars become black holes?
Yes.
That one?
I know that all stars don't become black holes. I just didn't catch how
They were formed. Okay, when a really massive star runs out of fuel, or you could say nuclear fusion stops, that's what the fuel is well, the fuel is hydrogen and other gases, and fusion is how those atoms are being pushed together. So once fusion stops and there's no more fuel, now there's nothing keeping the star from staying circular, round. Gravity collapses the star in on itself. So once a really large, massive star runs out of fuel, nothing holds it apart anymore, and gravity pulls it all in, all this mass into a tiny, tiny point. So it just becomes so dense that nothing can escape. Everything just attracted to that tiny point.
Okay.
It kind of reminds me of when we were talking about the size of an atom and like what an atom looks like. And remember that like video analogy they were saying if like that, if they blew up an atom the size of a football field and then the nucleus was like a marble, and then like all of that, all of the mass of like every automobile in the entire world into the size of a marble. That's how dense an atom is, the nucleus of an atom. It's very similar idea in a really large star, is that all of that massive amounts of, mass, dirt and dust and gas, of a star gets all, pressured down into this tiny, tiny little point, a point where nothing can escape. Okay, great. So if anybody has any questions they want to stick around and ask me after class, you can stick around and do that, or you can head on out and catch the video later if you missed it. I know there's some of you like Nicholas, I think you're here. You came in like 10 minutes ago. So feel free in about 40 minutes, maybe 30 minutes or less, actually. This video will be posted on YouTube. You can watch that. All the videos that we have, shown that the presentations are all on YouTube. If you want to catch any of them there, or if you want to stay talking to me now, or you want to show up for office hours, you got options. But don't forget to turn in project space. This packet is due tonight by 8. All right, and study guide is due on Tuesday before class. All right, I'm here if anybody needs me. I'll stick around. Otherwise, Toodles, have a good Friday. Okay. All right. Hi, Saya. I know you can't talk to me, or maybe you can now. Hi. How you doing? Are you still muted? Wonder if I can unmute you. Hey, Saya, can you hear or can you respond? No, still having some trouble. Okay. All right. Oh, no, you're saying you're good. No problems. Okay. Yeah. Oh, Brooke was asking me if there's actually stars larger than our sun. And yes, that answer is yes, but Brooke's not with us anymore to hear that answer. Oh, no problem. Saya, I'm sorry you were having technical issues. It's probably due to all this stormy weather. But thank you very much for showing up to the class, persevering through it, and also sending, what you could via chat. So that was helpful. Thank you. You did a good job. I don't. So I'll see you later, I guess. Do you want to say anything else to me via chat? Maybe not. Okay, bye. See ya.